Hello students. Today I'm going to be making this 11.6 day one video kind of um, in hindsight here. I didn't get a chance to record a video during any of the lectures on that day. So just a quick little review of this quadratic formula. So here's the formula. Okay, we need to be in standard form first. And some of the questions that came up in the homework for some of these problems were just using the discriminant here to decide how many solutions we're going to end up with. And the reason that we end up with two solutions for a positive is because when you take the square root of a positive number, like the square root of 25, technically you could end up with 5 and negative 5, right? So that's where those two solutions come from. One solution when you take the square root of 0 is because the square root of 0 is just equal to 0. There's not a positive and negative 0. So that's where you end up with the one solution there. And then the reason that we have no solutions, no real solutions when we get a negative is because we cannot take the square root of a negative number. If you were to type in the square root of negative 25 in your calculator, it would say error. That's going to be imaginary numbers that you're going to deal with in Algebra 2. Okay, so that's where the discriminant comes in with those couple of questions. And the rest of that is kind of just almost little fun facts here that we talked about in class that tie everything together between the graph and the equation and the quadratic formula. So with these first couple of examples, again, I'll just do a couple of these here because we did this full set of notes in class and I do have the notes completed on the checklist. When they're asking for you to compute the value of the discriminant to find out the number of real solutions, the first thing we have to do is we've got to decide what your A value is, what your B value is, and what your C value is. So that's the first step in any of these quadratic formula questions because we've got to plug those in to begin with. So your A value is what's in front of your x squared, so your A here is negative 4. Your B value is in front of your x, so that's a positive 6, and your C value is that constant at the end, so in this case it's going to be a negative 1. So when we've got that B squared minus 4AC, okay, so we're just plugging these things in. So my A of negative 4 will go in here. My B of positive 6 will go in here, and my C of negative 1 will go in here. So when I go plug all of those in, I'm going to end up with 6 being squared minus 4 times negative 4, and then again multiplied by negative 1 this time. So we make sure we have those plugged into the correct spot. And now it's just order of operations. So that 6 squared is going to be 36. And then I have to multiply all these things together. So negative 4 times negative 4 is going to be a positive 16. And then positive 16 times that negative 1 is going to be negative 16. So I end up then with 36 minus 16, which is going to be 20. So if my discriminant is equal to 20, and if we scroll down here, those questions are at the bottom. If my discriminant is equal to 20, that is a positive number. The discriminant of a positive number means that we're going to end up with two real solutions. Okay? And then when you're actually solving, excuse me, quadratic formula, I'll do one of these because that's what most of your problems on Alex ended up looking like. Remember, we have to end up in standard form, like these next two examples, which are on the completed notes on the checklist. We have to have all those values on one side before we can do anything with the quadratic formula. So when you see problems like this, the first thing we need to do is get that term from the wrong side over to the side with everything else. So we want everything, the ax squared, the bx, and the c, all together on one side equal to 0. That's when we're in our standard form. So the way that I'm going to move this negative 1, I'm just going to add it to both sides. I'm going to do the inverse operation so it cancels out from the side I don't want it on. And now I end up with 8x squared plus 7x, and then a positive 1 because that's what I did to both sides. And now we're equal to 0. Now we're in standard form, and we're able to get that a value, the b value, and the c value. Okay, so my a here is 8, my b is 7, and my c is 1. And now I'm just plugging this into that quadratic formula. So I've got x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so when I go to plug these things in, I'm going to end up with x equals, the opposite of b is going to now be negative 7 plus or minus the square root of b squared, so 7 squared, minus 4 times a, which is 8, and c, which is 1, all over 2a, which is 2 times 8. Okay? So we've got everything plugged into the correct spots, and now it's just order of operations. So with order of operations, the first thing I'm going to worry about is what's going on in that square root situation here. So my 7 squared is going to be 49. Okay, so I've got x now equals the opposite of 7 plus or minus the square root of. So 7 squared is going to be 49. And then this negative 4, oops, not mean to be erasing, this negative 4 times 8 times 1. So negative 4 times 8 is going to give me a negative 32. And then anything times 1 is just going to be itself, so I end up with a negative 32. So I have 49 minus 32 inside that square root, all over 2 times 8, which is 16. Okay, so the only three things I did there was I did the 2a on the bottom, I multiplied that out, and I took care of the two separate multiplication pieces inside the square root. So we continue to go down. Now I'm going to simplify that square root all the way. So that's going to be x equals negative 7 plus or minus the square root of 17. 49 minus 32 is 17, all over 16. And then when I actually take the square root of 17, and they want you rounding everything to the nearest 100th, I believe, on Alex. So the square root of 17 is going to end up being 4.12 when it is rounded to the nearest 100th. So I end up with x is equal to negative 7 plus or minus 4.12 divided by 16. So here's where we end up with a couple extra things that have to happen. Okay, so what I need to do here, this plus or minus symbol means that there are really two solutions going on here. One is adding the 4.14 to negative 7, the other is subtracting. So there's two situations. So I've really got x is equal to, one of the possibilities for x is when negative 7 is added to 4.12 over 16. And the other possibility for x is when 4.12 is subtracted from negative 7. Minus 4.12 divided by 16. Okay, so I'm going to go ahead and simplify these using a calculator. So on my calculator, I've got negative 7 if I can find the plus minus button on this calculator. Okay, here we go. Negative 7 plus 4.12 is going to give me negative 2.88, and then I divide that right by 16. I should end up with x is equal to negative 0.18. Remember, rounding to the nearest 100th. And then on the other side of things, when I've got negative 7 minus 4.12 divided by 16, I'm going to end up with x equals, rounded to the nearest 100th, will be negative 0.7. Now, again, Alex does want you rounding all the way out to the 100th. So I know for a fact on Alex, they're going to make you put that negative 0.70. They want fully out to the nearest 100th. So those would be your answers. And that was kind of a quick little flashback look back at day 1.